I remember when I started to learn game development, using Raycasts was something new and really cool. Like, whoa, you can shoot lasers in any direction you want, detect stuff accurately. That's pretty nice. But then, like a noob, I was worrying about performance in the completely wrong way. Like, is raycasting every frame okay? 10 raycasts too much? Ooh. So today we are talking about raycasting, performance and optimization, and hopefully this will help you increase your raycasting game. Let's get into it. I have a few examples for you that we can talk through. So the first one, of course, it's a bit old, 2003, but it's a great start into this topic. So Festive Vector, I have been working on an improved method for detecting navigation obstacles. Think I'm into something now. This costs 1 raycast per frame and maintains a radar around the boat that I can use to adjust the steering on the fly. So you see here we have the boat and he's raycasting every frame in one specific direction. So like a radar, it's actually very visual. It's self-explanatory. So I don't know how many balls there are all around or how many targets there are all around, but basically doing all of those, I don't know, there might be like 20 or maybe even more raycasts that you have to do. Doing 20 raycasts per frame, would that be a big performance hit? Well, the answer is it depends. Depends what is your target frame rate, and it depends what other kinds of stuff are you doing in your game that might cost also in terms of performance. But just saying too many raycasts is costing performance is not untrue. It's just not accurate. It always need to put it in the context of what you are trying to achieve. But one way to optimize raycasts is, and I think so many tutorials are missing this part, is that you don't need to raycast everything that you have to raycast on the same frame. Like you can split the work on multiple frames like you do here. So every frame you just do one direction. And gameplay wise, it still fits the goal of what you're trying to achieve, but performance wise, you are winning so much because now you're just doing one raycast. And the trick here is that whatever you are raycasting, that result of that raycast, you just need to store that result and remember that. So here he raycasts in one direction, it detects a rock, it just remembers that, oh, here there is a rock, so probably for the next few frames there will be a rock there. So that's a good way to think about that. I think it's clear. If you use Unity, this is clearly Unity, all the gizmos and so on. And that's a pretty good solution. Now, I was checking the comments. There are, of course, improvements that you can do to this. You know, maybe you can raycast less behind you and raycast more what is in front of you, because what is behind you is less important since you are moving into the forward direction. So there are many optimizations that you can do. But what is important to know about is what is actually the target frame rate that you want to achieve. So, and for that, well, you need to decide, okay, do you want to do 30 FPS? Do you want to do 60, 120? If you target 30 frames per second, target frame rate is 30 FPS. Let's make it bigger, like this. If your target frame rate is 30 FPS, then your frame per budget is 30. Up. Budget. So this changes, of course. Like if it is 60 or 120, well, this becomes 16 and this becomes about 8. This is why, optimizing game is important, but doing a jump from 30 to 60 or from 60 to 120 is pretty tough. Supporting higher FPSs requires a lot of work. So here's another example from AstroCat. This one, Minions Art, he's posting so great things. I like to see what he's doing. My controller, character controller, a rigid body controller. He developed his own controller to show that, well, his goes upstairs much more smoothly and so on. I can link the article later so you can read it for yourself, but I want to just focus on one little aspect here, so I'll go down. It is how he is implementing or using raycasts to detect the floor and make his controller. So the floor raycast, it seems that there are 4 rays, so 2 on each side. So center the one in the middle and 4 around by using different offsets of the ray origin, return the average. Oh, okay, so that's not 4, that's 5. So there's 1 in the middle, probably for the ground, and then 4 around for the rest of the feature. And this shows you like, okay, you should not be afraid to do a few raycasts. Like if your character controller needs 5 raycasts to make sure that it walks correctly on the floor, then do your 5 raycasts. If you need a raycast to position your hand correctly on a wall or touch things, then do that raycast. If you measure that and you see, okay, my raycast budget is too high, I need 5 milliseconds to do all my raycast per frame, well, then you can look into it and say, okay, which raycast is less important to do every frame, and those you can then push on the next frame or the next frame after. So let's check quickly the Unity API, because there are also other ways to optimize. So one way is, of course, there's Raycast all. Okay, so it returns all the hits from array, and there's Raycast non-alloc. Okay, and the Raycast non-alloc is like Raycast all, but generates no garbage, and this is super important because garbage is, at some point your garbage collector in Unity will have to clean up all the garbage that is laying around. And there are ways to trigger the garbage collector manually. You can do that. And that's actually a good practice. For example, if you have any kind of loading screens or an elevator or something like that, that's a good moment to say to the Unity API, hey, how about you clean the garbage now? Because those are like low gameplay moments. They are anyway waiting times for the player. So you can allow yourself to have a little drop in performance just to clean up the garbage. But otherwise, if you have very, let's say, active gameplay and all your raycasts are generating garbage, that's going to cost you not just in terms of performance per frame, but when the garbage collector hits, it's going to give you a spike in the milliseconds per frame, and then your frame rate will drop. So that's what we want to avoid. So of course, it's a bit more, let's say, work to use a non-alloc version, but it generates no garbage. And this is a free win. It's kind of a free win, okay? Of course, you can go next level, use Unity dots with the Unity physics API, and you have these collision queries, This works along with dots and ECS and this kind of stuff. This is really when you need the high performance. Then you go to dots and so on, and then you will use these types of API. It supports, I'm not sure it is explained here, but it supports, I think, creating jobs for raycasts. So instead of casting array and directly waiting for the result, you schedule the casting of the ray and you will get the result later. So it's like a job. Because the raycast itself, in the normal way, in the standard API, the raycast is blocking on the main thread. So that's why, okay, doing too many will reduce your performance, but what is too many? We don't know. It always depends what budget you are targeting, okay? What FPS you are targeting. Because this is your budget. Those are the secret numbers. You need to just remember those because those are 6 secret numbers. If you think that you want a game that goes 120 FPS, well, this is what you can spend each frame. So your game must do in 8 milliseconds everything it has to do to run to reach this amount of performance. Otherwise, your Steam reviews is going to be really bad and people is going to blame you for being a lazy developer. This is a cost. And this is why, 33 milliseconds is a lot of time. And it's super comfortable to make a game for 30 FPS. But gamers are like, no, I want 250 FPS and so on. So yeah, you need to work to increase that. So this is another interesting article. I will link it also below. Unity Raycast commands, a new era. And it talks a bit about this use case. You want to continuously check what is under the crosshair. Blah, 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 blah. You can read it. This is an example of the job-based raycasting. So you have native arrays. Those are the one that supports the burst compiler or the job system of Unity. I think it's a burst compiler, right? Wait till it's complete. And then if it's not, and when it's done, well, you schedule the next one. So this is checking the result of the Raycast, I think. And just here you schedule the next Raycast. So you say Raycast command is this one. Okay, you give your parameters, probably it has overload for the rest. And then you say schedule the batch of Raycast commands. So you can schedule multiple Raycasts at the same time. Just schedule them, and the next frame, you see if they are completed. Performance-wise, so trying to give a definite answer of how much does a Raycast cost is complicated because it's a physics-based action and it depends on your world. It depends how many objects you have, how many objects the ray goes through. It depends of your layer masks and so on. Whatever you do in your game, you create yourself a test scene and you test your Raycast and you see how much raycasting can you do with that feature that you have. So let's say you have your player that needs to do 20 raycasts every frame. Well, just try it out, okay? Just try it maybe with 40, with 60, with 100 raycasts and see those performance hits. Because if you optimize your game to, okay, in my game, the player can do 100 raycasts per frame, but most of the time, he will actually do only 20 raycasts. And if with 20 raycasts you are reaching already 60 FPS, then you know that your game is pretty well optimized and can support sometimes those a bit peaks and so on. But if at 20 raycasts you're already hitting those milliseconds budgets, then you know that, okay, if at some point in the game you need more, your game is going to start to stutter. Like if your game is already at the maximum during normal gameplay and then during boss fights, you know that it's more intensive, then you're going to have troubles. Like you should do other way around. You should optimize that it is super smooth for the worst case scenario that you will have in your game, and then the rest of the game will feel even better. That's how you should think about it. This one was interesting, just to show you. So this was a test, and I tell you again, this is in a certain context, so this is not a true for everything. And this is all the article. So it might be, the performance might be better, the performance might be worse. We never know. So you need to test your performance with your real environment. But well, I have taken a simple test on physics raycast for reference. I created a 2000 x 2000 terrain with dozens of 100 x 100 XYZ cubes. Then every frame I cast a lot of raycast from X 1000 Z downward. X and Z are among 0 to 2000. Okay, so it just has a big world, cast a lot of rays, and there are many cubes. So 2000 rays costed, in this case, 3 milliseconds per frame. And for 10,000 rays, 15 milliseconds. On a notebook with i5 and GT 445M. This doesn't mean that in your game 2000 rays will cost you 3 milliseconds. It really depends of the game. But those are things that are interesting to consider because it means that, oh, with 3 milliseconds, well, you know that your frame budget, if this is your frame budget, well, then you have minus 3 milliseconds, and then for the rest of your game, you have 30 milliseconds left. However, the 3 milliseconds don't scale, so for here you have 13 left, and for here you have 5 milliseconds left. So this starts to be tough, right? To target 120 FPS, and if you spend already 3 milliseconds on Raycast, you have just 5 milliseconds left for the rest of your game. All kinds of rendering, special effects, shaders, particles, dialogue, sound, and so on, they have just 5 milliseconds left. So it starts to get tough. Another test, interesting, a bit more recent, October 2024, so that's more interesting. So I've been searching about the performance impact between Raycasts and triggers. Yeah, everybody does. But most posts don't give an explanatory enough answer for newbie. That's true. Some say to test it yourself. Yeah, I just said that. Which is what I did. For those interesting, here are my results. So in all cases, I spawned 2,500 cubes, all with rigid body and colliders. In the Raycast test, each cube received a ray up, down, right, and left. In the trigger test, the test cubes received an extra and bigger collider to act as a trigger. So every cube cast a ray in each direction, in 4 directions, right? So he's reaching 168 FPS, so 5.9 milliseconds per frame. And you see here's a graph, some peaks here, and this is what I'm talking about. So of course, the big mistake here, so I'm not sure, but I assume that the big mistake here is that he's doing this in the editor. So if you want to measure real performance of your game, you have to go out of the editor. You cannot consider editor benchmarks accurate. So with that being said, we are still going to take a look because it can give us a trend, but it doesn't give accurate results. Okay. So if you want accurate results, you need to go out of the editor. So we see here he's around 10 ms every now and then, and sometimes a peak at 16. So you see those peaks, maybe they're from the editor, maybe they're from the game, but those peaks are dangerous because this is a stutter. Like you drop from 100 FPS to 60 FPS, and this is noticeable, and player will hate you. Now the trigger enter, the same with trigger enter, he has a bit less FPS, and you see the graph is different, so it's actually more stable. But you still have those peaks sometimes. So where those peaks come from, not sure. Trigger stay obviously will be a disaster because it's continuously checking. Complete disaster. So I don't think editor or out of editor will be different. This is total garbage. On an i5. So apparently on trigger enter is fine for his case, and Raycast has the ultimate performance for constant checking. Okay, that's what his result was. Box casting on 4 sides. Of course, box casting is always more expensive than raycasting. Raycasting is one line. Box casting is a mathematical computation to cast that box. I think, if I'm not mistaken, between all the shapes, I think the sphere cast is the most performant after the raycast. So between a box and sphere, the sphere is better, I think. The mathematics is simpler. So he reaches here barely 60 FPS with this frame budget. And you see here it's actually more stable than with the Raycast. So that's weird. So the Raycast had those peaks here sometimes, one peak here. So here seems more smoothed out. Overlap box. So 77 for checkbox. Oh, sorry, I skipped one. So box casts 58. Checkbox 77. I think checkbox in the Unity API is returning true or false. It's just a true or false check. It's just a check, like the name says, checkbox. And the box cast returns you the entire hit details. So you win a bit by doing a checkbox. You need to consider, okay, do you need analog, non-analog? Do you need to know, did I just touch something, or do you need the hit results? This is also making a difference. Overlap box doesn't look, it looks a bit more wiggly. Why is that? So we have 82 FPS, 12 milliseconds. And yeah, why is the checkbox at 77 and overlap box is more performance? I don't know. This is why you need to do the same test out of the editor. So, to be sure. So 4 rays did better than the rest. So that's interesting. So raycasting is great. When you look at performance and optimization, you should not really look at the frame rate. Like, the frame rate is interesting, but what is the most important is your milliseconds per frame. This is the most important. On your hardware, on different hardware, out of the Unity editor, this is the values that are important, not this one. This is computed based on this. So this is the value you need to take care of. So then once you know what is your budget, okay, you need to measure how much do your raycasts cost. And based on that, you can see, are you doing too many raycasts or not? It's really just what there is. And then you just test. But when you just start out with game development, you should not worry at all about performance. Is that a good tip? I'm not sure. So my point is, whatever feature you want to implement in your game, if it needs a lot of raycast, do your raycast. And then you measure how much your raycast cost. And if they use too many milliseconds from your budget, well then you need to think about how to optimize it. And ways we saw, okay, you can use the non-alloc version instead of the alloc version. You can split the work of the Raycast over multiple frames. You can switch to the burst compiler for Unity and use and schedule your Raycast on another thread, which is highly performant but requires more work. So there are all those methods to optimize your game that you should just keep in mind and apply when needed. But if you do just, like in this case, your 5 Raycasts under the character, I don't think you should directly schedule those with a burst compiler or do one per frame and so on. That's, let's say, premature optimization. And premature optimization is not good, but optimization is good. You want to keep a smooth FPS by controlling your budget that your game needs or can spend each frame. And now, like and subscribe, and then go work on your game.